So today we're going to expand on what we did yesterday. Yesterday we learned how to solve rational equations, and today we're going to take that concept and we're going to apply it to word problems. We're still in Unit 5. There are three main clusters of ideas in Unit 5 that you will be responsible for learning. The first is simplifying rational expressions. We worked on that on Monday and Tuesday. Wednesday and Thursday is the concept of solving rational equations, and then tomorrow we move on to graphing rational equations. So the three main concepts within this unit. Here is the first problem, and we're going to apply the same three rules we learned yesterday, and that is find the LCM of the denominator, clear the denominator, solve, and then check for extraneous solutions. Now it's going to slightly change in how we check for extraneous solutions. Hopefully you catch on as we go through more and more problems. As I stated earlier, my suggestion is not to write down the entire word problem right now. You just won't have enough time. I'm going to post this PowerPoint to your Teams page so you can go back and write it into your notes if you choose to. Ian can rake a lawn and bag the leaves in 3 hours. Kylie can rake the same lawn and bag the leaves in 260 minutes. Working together, how long does it take them to rake the lawn and bag the leaves together? So the first thing we always have to do is we have to make sure we're working in the same units. So we have 3 hours here and 260 minutes here. Now you may ask yourself, do they both need to be in hours? Do they need to be in minutes? That is your choice. I think that most students find it easier to change hours into minutes because they know that each hour is 60 minutes. So 3 hours is equivalent to 180 minutes. Now how we set up problems like this is all the same. We have two different, we'll say, subjects we're talking about. In this case, it's Ian and it's Kylie. And then we talk about what can they do together. So here it says that Ian can rake the lawn and bag the leaves in 3 hours. He can do this one task in an amount of time of 180 minutes. Kylie, on the other hand, can do the same task in 260 minutes. And the question says, together, doing that same task, how long does it take them? So I have set up the equation, the tasks on top, the amount of time it takes to complete the task individually for these two subjects, and together, this is the unknown. And now we're going to go through the steps. Remember, LCM, clear denominator, solve, and extraneous solutions. So in the past, if I said to you in the last couple of days, what's the LCM? I initially taught you by saying, write out all of the multiples of 180. So you'd have 180, 360, 540, and then I'd start with 260, 520. Okay, that's taking way too long. In the first 10 to 15 seconds, if it doesn't pop into your mind what the LCM is, then we're going to go with just a little bit. We're going to use the calculator to help us with this, basically. So the LCM, when you can't quickly figure it out, is I can see 1x, and then there's 180 and 260. I'm not going to spend 2 or 3 minutes just trying to find this LCM. This will help us, and a calculator will simplify it for us. So this is my original, just like yesterday when we went over the problems we had, like the bold black. Well, this is my bold black. So this has 180, so I'm going to cover it up. It's missing an x, and it's missing a 260. So over here, it's missing a 260 and an x, missing a 260 and an x. Remember to keep the value of this original fraction the same. Whatever you multiply in the denominator must also be multiplied, or we could say attached to the numerator. The second term, I cover up the 260. It has a 260. It's missing an x and a 180. The last term, it has an x. It's missing a 180 and a 260. So I've just completed step number 1. Step number 1 is identify the LCM and apply it. Now, before I move forward, I definitely want to make sure that I have correctly applied the LCM. 180, 260x, 180, 260x, 180, 260x. Okay, good. Step number 2 says we cancel out the denominators and we solve the top. So I know 1 times 260 is 260x. 180 times 1 is 180x. And I'm going to use a calculator to do this work. So would it be wonderful if you had a graphing calculator in your hand? Sure, but we don't have that luxury with virtual learning. So I'm going to flip over to the screen, and you can all see this, and I'm going to go to Desmos. Again, if you're wondering where did I get this, it's desmos.com. You're going to click on the graphing calculator. Not only is it a graphing calculator in terms of graphing functions, we also can use it just the basic concept. So I'm taking 180 and I'm multiplying it right now, 180 times 260. And I'm going to write down this answer, 46,800. Now if I glance back here, I want to add these two together so they're like terms and then set it equal to this value. That's what I'm going to be doing next. So 260, 260 plus 180 is 440. Coming back here again. This is 440x equals 46,800. To isolate the x, I divide. Remember, we often just cross it out. We think it cancels, but in reality, it divides into 1. And now I'm going to divide this onto the calculator and make sense of it in terms of this problem. So I'm taking the 46,800 and I am dividing it by 440. So I can see this is not an exact answer. And when it's not an exact answer, what we're going to do is we're going to first make these little symbols. It means it's approximate. It means like I've had to round this a little bit. So 106.36. You may be asking like, well, how did you know how far to round? I'm just writing down this initial answer, and then I'm going to go back and see, does it say what I should round to? I prefer you always to have, if I could. I wish I could send out to you, or I wish you all had a printer at home. Not realistic, where you could have this in front of you. It's so nice to already have the worksheet or the assessment in front of you. And I would suggest, if you have that ability, to always highlight to identify what is the question really asking. The question is asking how long does it take them to rake along and bag the leaves if they are, the key is, if they are working together. Well, I got an answer of this. What does this mean? Well, X was the time it takes to complete the task together. So it's approximation, and for this particular learning task, you need to have a final answer that is going to answer this as a complete sentence. So I could write working together. It takes Ian and Kylie. The key is here, approximately. So it's already saying that I'm rounding, approximately 106, and I have to attach the units. Approximately 106 minutes to, and what are they doing? To rake the lawn and bag the leaves. And hopefully you've learned over the last quarter, or a little more than a quarter, that a lot of times I'm a minimalist with certain things. With this, you need to write a complete sentence so that if somebody comes back and reads your answer, they won't even have to know exactly what was the initial problem. They can know, okay, if they work together, this is what they could accomplish. It's not only just what the time is, what can they accomplish in that time? Can I have right now, just to give me a heads up, can you give me a 1 through 5 right now into the chat and how well you were able to understand that? Thank you for your participation. It looks like a majority of you are about a 3, which is a great starting point. All right, so here we go. We're going to move on to that's example number 1. Please write that in your notes. That is example number 1. Moving on to example number 2. And where I grew up in the Midwest. There was a lot of like decks, we call them decks or porches in the back of the house. In the desert where we live, I don't see a lot of decks. Sometimes in a 2-story house you'll see a deck out of like a bedroom, but I don't see a lot of them. And so here this is talking about two people, Anaya and Bill. Working together, Anaya and Bill stained a large porch deck in 8 hours. Last year, Anaya stained the deck by herself, and the year before, Bill stained the deck by himself, but it took him twice as long as Anaya. How long did Anaya and Bill take to paint the large deck when they each painted it alone? This is example number 2. Again, as I stated with example 1, I wouldn't take time to write this all down because I will provide you with the PowerPoint for those that want to go back. How do I start? Well, I look at what the subjects are. There's Anaya, there's Bill, and what they can accomplish together. Some students say, well, does Anaya go first? Does Bill go first? Is it based on the alphabet, alphabetically? Doesn't matter. Let's talk about what we do know. We know that Anaya is faster. In fact, she's twice as fast, or we could say Bill is twice as slow. They're the same concept. So think of this real quick. If you take you and your best friend, and you say that you generally outscore in math your friend, you do twice as better. Well, on a 100-point assessment, if you received an 80, that means your friend received a 40. If you received a 90, your friend received a 45. You did twice as better, or they did twice as worse, right? So how do we set that up? Well, we do have to set it up in a way that shows us what do the variables mean. So I'm going to say x. X equals the time it takes for Anaya to stain the deck by herself. And what we know is that Anaya not only is faster than Bill, she's twice as fast. And so it is easy to make small mistakes here. And so I often suggest that after you come up with defining what the variables mean, that you go back and just plug in some arbitrary numbers to make sure that it does make sense. So I know it takes Bill twice as long to do the same task. So x is the time it takes for Bill to stain the deck by himself. Now know that for your checkpoint quizzes, and by the way, I think you have 3 or 4 on just these type of concepts before you take your next test, 3 or 4 different questions, there is a question where you have to define the variable. So I would definitely suggest you write this down in your notes. This is example number 2. Now let's make sure that this does make sense. I'm going to use a number like 20. So if 20 represents the time, so 20 is going to be substituting for x. If 20 is the number, 20 minutes is the time it takes for Anaya to stain the deck by herself, and then I substitute that same 20 in for x here, 20 times 2 is 40. That makes sense. 20 minutes for Anaya, 40 minutes for Bill. Or if we did hours, if it's 3 hours for Anaya, it's 3 times 2, it's 6 hours for Bill. So it's twice as long for Bill, and that makes sense, twice as long for Bill. He took twice as long as Anaya. Okay, good. So I feel comfortable with that. So it's the task you're doing of painting the deck by yourself. Anaya is represented by x. Bill is represented by 2x. And together we know they can paint it in 8 hours. Okay, we go back to our steps right now. We're going to identify the LCM and we're going to apply it. So this is an x, this is a 2, this is an x, and this is an 8. Notice that the 2 and the 8, they seem stuck together, but they're separate things hanging out by each other. X plus 2 is different. X plus 2 is like a couple I referred to yesterday. These are just 2 things hanging out by themselves. So LCM, we have a single x. Okay, so I'm going to cover those up. And then we have a 2 and 8. What is the LCM of 2 and 8? If that's confusing for you, I'm going to write 2 and 8 up here, and I'm going to find the LCM. 2, 4, 6, 8. 8, 16. The smallest number in both of these lists would be 8. So the LCM is 8x or x8. Now I'm going to apply that. This is the original. Keep that in mind. This is missing an 8. So 8x, okay, whatever you do to the bottom, you must also do to the top to keep the original fraction with the same value. So this has an x, great, but it only has a 2. I don't want a 2, I want an 8. We can only bump this up to an 8 by multiplying or dividing. You can't add something. So I'm going to multiply by 4, both top and bottom. This has an 8, it's missing an x. So I've completed step number 1. I've identified the LCM and I've applied it. Now I cancel out the denominators, and I only focus right now on the numerators, and I'm going to solve it. This is not 81. This is 8 times 1, 4 times 1, 1 times x is 1x. Well, that seemed pretty easy. Now, we need to make sure, this is checking extraneous solutions, we need to make sure that this does work. So, here we go. X equals 12. Again, I've done step 1, step 2, cancel out, step 3, solve. Step 4 is check for extraneous solutions. Does it make sense within the context of the problem? So I plug in 12. So remember, we're talking about hours here. So if it takes 12 hours for Anaya to stain the deck by herself, that means 12 times 2. It would take 24 hours for Bill to stain the same size deck by himself. Okay, that makes sense. What do we do now? We go back and we identify what is the question. How long did it take both individuals when they painted the deck by themselves? So it would take Anaya and Bill 12 hours and 24 hours to, oh, not stain, to, not paint, to stain the deck individually. And I'm going to write the word respectively behind. And what respectively means is that it means that when I provided two numbers, that the first number goes with the first name. It would take Anaya and Bill 12 hours and 24 hours, and I could say respectively, to paint the deck by themselves or individually. Again, respectively just means the first name goes with the first number. So Anaya takes 12 hours, Bill takes 24. Just to clarify, you don't need to write it down word for word as I have done, but what you do need to do is that if I read your answer, I need to pretend as if I've never even looked at this problem, that I know exactly what the task is, and I know exactly how long it takes each individual. Can I have a thumbs up or a thumbs down if you understood how I took the word problem, I broke it apart, set up the equation, and did steps 1 through 4? Thumbs up or thumbs down? Don't hesitate to do a thumbs down. Okay, we are moving on right now to example number 3. This was a rather difficult problem for a lot of students. So taking baby steps here just to help you prepare to be able to do these by yourself, I want you to read the prompt yourself and see if you can draw a picture that represents or models this information. I'm going to give you 1 minute to do that. Okay, so I'm going to draw a picture, and in no means am I an artist here. So we have a small fish pond. There's my pond, and yeah, that's a large fish in this pond. That's my best work. Okay, so this is a fish pond, and there's two different sized water hoses that are going into this pond. And I'm going to draw them in different colors just so it's easier for us to identify the difference. One is referred to as the long hose, So this is a really long hose here, and so we have water going in here with this long hose, and then we have a really short hose hooked up here. We have a very short hose that the diameter of the hose may be different, or the water pressure coming in may be different. And this particular problem says we have two different hoses being used to fill the small pond, and together the two hoses, when they're working at the same time, they can fill this small fish pond in exactly 12 minutes. So it must be pretty small. If used alone, the shorter of the two water hoses is able to fill the small fish pond 10 minutes faster. So shorter can fill it faster. That means the water pressure, the amount of water coming out of this hose must be greater. It can fill this pond 10 minutes faster than the long hose. So I'm just going to write here, this is the slower hose, and this is the faster hose. We have two subjects. We have short hose and we have long hose, and then we have together. So my subjects would be the short hose plus the long hose, and then together. And now I need to identify, what's really happening here. So let's talk about this. There was a lot of confusion earlier about this, and so let's relate it to like you running. If you ran once around the track and it took you 90 seconds to run around the track, this is you. And I said that you have a friend who's just a little bit faster than you. Okay, and this is your friend, just a little bit faster. So if it takes you 90 seconds, we know that it would take your friend 80 seconds. They're 10 seconds faster. Could it be 70 seconds? Sure. I just made up 10 seconds faster, so it kind of relates to this. So if I say that X represents the time it takes you to run one lap, and then I need to represent an expression based on how fast you can run. Well, your friend, if he consistently runs at the same pace, he's not just X, he's just slightly faster than you, and I clocked him at 10 seconds faster, so I'm going to write X minus 10. This is your time to run once around the track. This is your friend's time, okay? Let's relate that over here. So if I say X equals time taken to fill small fish pond by shorter hose. X is the time it takes to fill the fish pond by the shorter hose. If that's the case, and there's more than one way we can do this, let's look at this. I'm going to put right now, and I'm going to change one of these. I'm going to put X equals, and I'm going to change time taken to fill small fish pond by longer hose. Now we know they're not the exact same amount of time, so let's come back here. It says, if alone the shorter hose, the shorter of the two hoses, is 10 minutes faster. So this one is 10 minutes faster. So it takes less time with the smaller hose. It's 10 minutes faster to fill this. 10 minutes less is really what they're saying. So how do I do 10 minutes less? It's X minus 10. Again, as I've suggested in examples 1 and 2, my suggestion is just to make up an arbitrary number, similar to what I did here, and let's take, 100 minutes. If it takes 100 minutes for the fish pond to be filled with the longer hose, 100 minutes, then that same number, 100 minus 10, it would be 90 minutes to be filled by itself using the shorter hose. Let's see, does that make sense? The shorter of the two water hoses is able to fill the small pond in 10 minutes faster. 10 minutes less. So these are my two expressions. Now I come down below. I have 1 over. I will tell you that this caused most students in the previous hour the most difficulty in understanding how to set up. So the shorter hose is going to be represented by X minus 10. 10 minutes less, 10 minutes faster, 10 minutes less. The longer hose is 1 over X. And together it states that it can be filled up in 12 minutes. I know this is difficult. Can you guys go into the chat for me? I'm asking everybody to participate who has a working chat. It also tells me that you are actively involved here in our lesson. Can you give me a honest 1 through 5 on your ability to understand how I set it up like this with the explanation? Okay, so now how does this differ? Thank you for your feedback, guys. How does this differ? Notice if we look at the bold black, I had an x, a 2x, they're stuck together, okay, so there's no plus or minus in between. Notice the differences of the previous problem. Well, now when I look at the bold black for this example, for example number 3, they're not stuck together. I referred to this yesterday as kind of like a couple, okay? It's not just an x and a 2 like the last problem. It's not separate, an x and a 2 staying together. These are together. It's not an x and then a negative 2. These are negative 10. These are together. So that's one group, there's another group, and there's a third group. So when I identify the LCM, the order I write these in doesn't matter. There's a 12. There has to be a single x, and there has to be an x minus 10 together. That is the LCM. Step 1 is identify the LCM and apply it. I cover up and I cover up. It's missing not only an x, but also a 12. I'm missing a 12 and an x. The middle term, I cover up the x. Not only is it missing a 12, it's missing an x minus 10. It's missing an x minus 10. How did I determine that for people that are confused? I cover it up, missing a 12 and an x minus 10. Finally, it has a 12, it's missing an x and an x minus 10. Okay, what do we do? Okay, so here we go. So I am going to cross out, cross out, cross out, cross out, cross out, because I've identified the LCM and I've applied it. Okay, I've identified it and I've applied it. Now I come up to the top, 1 times 12 is 12, so I have 12 with an x. Okay, now watch here, I need to take the 12 times 1, and then I will distribute it to the x minus 10. 1 times x is x, and I will distribute it in the next step to the x minus 10. Okay, let's distribute here. So I have a 12x, okay, 12 times 10 is 120, and an x squared minus 10x. Okay, so again, I'm a minimalist when I can be. Notice that I have the 5 different terms, but what's different about this problem compared to example 1 and 2 is I now have an x squared. So I want to move everything to the same side as the x squared, and this is where I'm going to get lazy. Because the 12x is added over here, if I move it to the opposite side, I just change the sign. So when this moves over, it becomes negative 12x, and a positive 20. So this is where I'm going to be lazy. I move it over, done, I move it over, done, and I move it over, done. And then I cross them out. So I have nothing left on the left-hand side. And on the right-hand side, I'm going to combine. There's only one x squared, negative 10, negative 12, and negative 12. Well, I know this is negative 24, and negative 34x plus 120. So when you get to this point, remember for quadratics, you can solve by factoring, but it doesn't always work. You can always solve using quadratic formula or using completing the square. I prefer to use factoring because when it does work, it saves me a lot of time. So let's see here. 1 and 120 don't give you negative 34. 2 and 60, no, that doesn't work either. 3 and 40, well, I'm getting close, I'm down to 37. 4 and 30. 4 times 30 gives you a positive 120, but it does not equal, it does not equal negative 34. But if I make them both negative, now they multiply still to equal positive 120, they combine to equal negative 34. So it's x minus 4 and x minus 34. Oops, sorry, that's a 0, an equal sign. The nice thing is the leading coefficient's 1, don't have to worry about bottoms up, and I can simply solve. So remember, step 1 is LCM, step 2, cancel denominator, step 3 is solve, step 4 is to check for extraneous solutions. But with word problems, there's like an extra layer of checking for extraneous solutions. So like we learned yesterday, look at the bold black. If there's, oh, sorry, did I write this down as 30? How about that? Better? Thank you for finding that mistake. This should have been a 30, not a 34. Thank you. So I go back up to the bold black, and if there's no variable in the denominator of the bold black, I just get to bypass it. So bypass, when I plug in 4, okay, it's not 0. I plug in 4, it's not 0. Then I go up to 30. Okay, I don't have to, there's no variable here in the bold black, so I bypass. Plug in 30, we're good. Plug in 30, it's not 0. Okay, so it's passed the test in terms of what we learned yesterday. And yesterday was you can never have a 0 in the denominator once you substitute in these numbers. But now for word problems, checking for extraneous solutions, and this bothers me because that's kind of messy. Checking for extraneous solutions means that common sense needs to be applied. So I'm going to come back up here. Remember, we got answers of 4 and of 30. Let's check these out. Let's start with 30 here in the bottom. Does this make sense? So could it be that the small pond could be filled up with the longer hose in 30 minutes? Yeah, that's true. And if it takes 30 minutes for the small pond, substitute it in, it would take 20 minutes for the shorter hose. Yes, that makes sense. So that's a true one. Let's check with the next one. Can it be true that it takes 4 minutes to fill up the small fish pond using a longer hose? Okay, good. And then substitute it in. 4 minus 10 is -6. And it takes -6 minutes to fill up the small pond using the shorter hose? Well, there's no answer that's going to have. Time is like distance. Time and distance will always have a positive answer. They'll have 0 or a positive answer. And so you can't have a negative amount of time. That means this is extraneous just by common sense. And so the answer is 30. But now, with word problems, again, this is where I wish you had this paper in front of you. We're going to highlight the question. How long does it take each water hose to fill the small pond? So I would write the final answer. It would take, and again, you can vary it a little bit. Just know that it would be like if you took this to a sibling and said, read this, do they understand the task and the amount of specific time for each task? And if they do, then you know that you have a correct answer in terms of being detailed enough. It would take the longer water hose 30 minutes to fill the small fish pond, and it would take the shorter water hose 20, because we have 30 minus 10, 20 minutes to fill the same small fish pond. Okay, I appreciate your honesty. The last two problems we have had an average. We've had an average of a 3. That's okay. Can I have a 1 through 5 on your level? Remember, there's a lot of steps here. It is first taking this problem and setting up the equation and the variables. Then it's steps 1, 2, 3, and 4. LCM, clear denominator, solve, check for extraneous solutions, and then make common sense of it. So can I have a 1 through 5 if time is not a factor on your confidence that you're building with this type of problem, your understanding? Give me 1 second to find your next problem. I'm going to have you guys help me out. Is this example number 4? Can somebody let me know? Example 4? Yes, no?
Yeah.
Okay, thank you. Example number 4. Okay, working together, Jennifer and Lori can plant a vegetable garden in 3 hours. If Lori works alone, it takes her 8 hours longer than Jennifer to plant the garden. How long does it take Lori to plant the vegetable garden by herself? So how do I start this? I always identify what are the two subjects. And again, whether you put Jennifer first or Lori first doesn't make a difference. So Jennifer and Lori, and then the together. And what's the task? It's planting a vegetable garden. One part is if they do it together, and one part is if they do it individually. Okay, let's see what's happening here. So if I go up, it says it takes, let's see, if Lori works alone, it takes her 8 hours longer than it takes Jennifer. So Lori is slower. Lori is slower. Jennifer is the quicker one. There's a couple different ways that you can do this, but in the end your answer would be the same. Your final answer would be the same. So I'm going to have x equals time it takes, and I choose to do the faster one first. So I know Jennifer is faster because it says it takes Lori 8 hours longer. So I'm going to do the faster. Time it takes Jennifer to plant the vegetable garden individually, which means by herself. And then I'm just going to write, at this time, I'm going to write x time it takes. I'm going to adjust that. Lori to plant the vegetable garden individually. Okay, now let's adjust it. So let's make this up. I have no idea. Let's just say 10, for instance. We know Jennifer is the faster person, and this says how much faster she is. So if it takes Jennifer 10 hours to plant the vegetable garden by herself, 10 hours, that means it would take Lori 18 hours because she's 8 hours slower. It takes her 8 hours more to do the same task. So let's readjust this to x plus 8. I'm choosing 8 because it says it takes her 8 hours longer. Let's do one more. Let's say it takes Jennifer 5 hours. Well, if it takes Jennifer 5 plus 8 means it would take Lori 13. I'm using arbitrary numbers. So I come down below. This task, this one task, we're going to say it takes Jennifer X amount of time. Lori's X plus 8, and together it says they can plant it in 3 hours. Remember, this is one item, this is the second, and this is the third. So there are technically 6 things you're going to be doing here. You're going to be doing the LCM, don't get started yet, and applying it. You're going to clear the denominator, you're going to solve, you're going to check for extraneous solutions both within the problem and the common sense up above, and then you're going to answer the question with a complete sentence. I'm going to give you a minute head start, and then I'm going to start working through this quietly without talking through the process so it does not interrupt your learning. Okay, 1 minute head start, please begin. please be responsible for your own learning and never hesitate to ask questions, whether you put an E into the box this time, into the chat box, or you unmute yourself. Let me know. Does anybody, before I check for extraneous solutions and we come up with an answer to the question from this problem, does anybody need help identifying how I came up with the LCM, how I applied it, and solved? Okay, I'm not seeing an E, I'm not hearing anybody, so I'm going to move forward. I'm going to start with a 4 here. So I'm going to start with a 4. So positive 4. I look at the original. This doesn't have a variable. I move on. It does have a variable. 4 plus 8, good. It does have a variable 4. Okay, good. That's good. Now let's try negative 6. Doesn't have a variable. I bypass it. Plug in negative 6. Okay, good. Plug in negative 6. Okay. None of them equals 0, so let's move on to what is the common sense now. So I'm going to start with 4 again. Is it possible that it takes Jennifer 4 hours to plant the vegetable garden by herself? Yeah. Okay, take this 4 and substitute. Is it possible 4 plus 8 is 12? Is it possible it takes Lori 8 hours to plant the vegetable garden individually? Yes, it is. So I like that answer. So x equals 4 works for me. Let's try negative 6. Is it possible it takes Jennifer negative 6 hours to plant the vegetable garden by herself? Not possible. Remember, time is 0 or above, so that is considered to be an extraneous solution. It doesn't just have to be negative to be extraneous. You still have to plug them in. They could both be positive, and we'd have to check. Now we go back to the problem. How long does it take Lori to plant the vegetable garden by herself? So I go up to the expression that represents Lori. When I substitute in 4 for x, because 4 is the answer I received, 4 plus 8 is 12. So I would write a complete sentence that says, it could be something similar to this, it takes Lori 12 hours to plant the vegetable garden by herself. Remember that your complete sentence has to include what is the time, who is it, and what is the task. I appreciate your continued feedback for me because I know this is difficult. I didn't want to just send you out with problems to see could you do them on your own and not have anything to check or help you with. Can I have right now only a thumbs up in the chat if you feel like your understanding with each problem is growing? If you feel like I feel like I'm kind of the same or that it's even less, don't give me a thumbs up. That's okay. I just want to know, do you feel with each problem like you're gaining a better understanding? Oh, don't ask me what's happening there. Thank you for those that are participating. Okay, I don't care about separating hours and minutes, so we're going to look at this problem together. Perla can paint the outside of a small house in 10 hours and 15 minutes. Maria can paint the outside of the same house in 9 hours. How long would it take them if they worked together? So how do I initially set this up? I set this up, who are the subjects or the individuals, the task, and what they're trying to do together. So I have Perla, Maria, and what can they do together? Remember, you need to have the same units. So yeah, they both have hours, but then they throw in 15 minutes. Now some of you know that 15 minutes, like for instance, 1 hour is 15, 30, 45, and 60. So 1 hour is split among 4 15 increments. So this is really 10 and then 10.25 representing 25% of an additional hour. Not many people can do that in your head. So what I have found that most students feel more comfortable with is let's switch them all to the same unit and we're going to put them all into minutes. So I'm going to turn 10 hours all into minutes and then add additional 15 minutes. And then I'll do the exact same thing for Maria. And if you had an individual calculator, it'd maybe go a little bit faster, so we're going to switch over right now. And again, I'm going to take those 10 hours and I'm going to switch them all into minutes. So that would be the 600 minutes is equivalent to 10 hours. So 600 minutes plus an additional 15. So Perla's at 615 minutes. And now I'll do the same for Maria. So Maria is at 9 hours exactly, so if I take 9 and take it times 60, we get 540 minutes. All right. Okay, so what do we know? We know that the one task of painting the outside of a small house can be completed by Perla in 615 minutes. For Maria, it's 540, and we want to know together, what can they do? Doing the same house together, how long does it take? How many minutes? Okay, so this is an example where if I said, okay, find the LCM, we know it has to have an X, but the time it would take you to find the LCM of 615 and 540 is way too long. When that's the case, we just attach them both, and we'll let a calculator help us work with the big numbers. So this is missing a 540 and an X. This has a 540. If I cover it up, it's missing a 615 and an X. As a reminder, whatever you attach to the bottom, you must also attach to the top. This has an X and it's missing a 615 and a 540. And we cancel at the bottom. Okay, so I have 1 times 540, 1 times 615, and a really large number here. Now, I've already done this with a previous class, so I'll tell you that if I took it and multiplied this in decimals, we'd end up with 332,100. And I'm going to continue to solve again. So I'm going to take 540 plus 615. 540 plus 540 plus 615. Make sure I added those correctly. Here, give me 1 second, okay? And now to isolate the X, I'm going to divide both sides by that value. And let's see what we get for an answer. Maybe approximation. Maybe not an exact minute. So that divided, oops, excuse me. All right, so I'm going to write down on my paper what this is approximately. And then I'm going to go back and I'm going to highlight what is the question we're trying to answer. How long would it take if they worked together to paint the outside of a small house? So when you write this answer down, we're going to use the word approximately because it is round. It is rounded. We're going to use the word approximately. Now, whether you say 287 or 288, I'm not getting caught up on that as much. I would be specific so it's easier for me to grade in how I want you to round it. But it would be something like this. Together, as a sentence, together, it would take, so remember how long together. So who are the individuals? Together, it would take Perla and Maria approximately 287 minutes, remember say the units, 287 minutes, to paint the outside of a small house. So you've said who are the individuals, what is the task, and how long does it take. We have one problem similar to this before we move on to a different type of rational equations. One more painting problem. Thank you for your patience. And part of this problem was cut off by my picture, so I do need to change a little bit of that. Okay, so it would take them, Norma and Clara can paint the office in 2 hours and 40 minutes. Norma and Clara can paint the office together in 2 hours and 40 minutes working together. Being a professional painter, Norma can paint twice as fast as Clara. How long would it take Clara to paint the office by herself? Let's go through what you need to do. You're going to set up the equation. You're going to define the variables. What are your x's representing? Then after you set up your equation, along with those, you're going to do LCM, clear the denominator, solve extraneous solutions, and make sure it makes common sense before you answer the question with a complete sentence. A lot of work. I'm going to give you 4 minutes, and I'm going to get started after 2 minutes. Please begin. I'm going to stop you for the sake of time. There's the subjects of Norma, Clara, and doing stuff together. We know Norma is a professional painter and she can paint twice as fast as Clara. First I started off with X representing the time it takes Norma and the time it takes Clara to individually paint the office. And then I went back and read Norma is twice as fast. So whatever Norma is, it takes twice as long for Clara. Twice as long. 1 second, I'll come right back to you, okay? Unless I made a mistake, I'll come right back to you. So for instance, if it takes, let's say, 3 hours for Norma, 3 times 2 is 6. So it takes 6 hours for Clara. That's how I set these up. So there's Norma and there's Clara. Now, let's look at the LCM here. Let's see if I made a mistake here. I had a question. So these are individual. X and X are the individual X's. And then I looked at 2 and at 160. And I tried to find the LCM of 2 and 160. I had students in a previous hour say, I don't understand how you got 160. Well, it says together they painted the office in 2 hours and 40 minutes. So each hour is 60 minutes. So there's 1 hour and 2 hours and an additional 40 minutes. 60 and 60 is 120 plus 40 is 160. That's why I have 160. Now let's relate this back to the LCM. So we know that X, a single X has to be the LCM. Now, how did I receive an answer of 160 for the LCM? Well, I knew it. If you didn't know these, you would multiply these and get 320, and in the end, you'll get the same answer. If you didn't know that, you'd multiply these. I know that if I start going by 2s, 2, 4, 6, 8, 10, 12, and I just keep going by 2s consistently in that pattern, that I would eventually get to 160. So 160 and 160 would be the smallest number in each. That's why I came up with this. 2x is not the same as x plus 2. These are two separate things next to each other. It's not the same as an x plus 2. Hopefully that helps to clarify. So the LCM would be 160x. So I apply that to the bottoms, and I solve the top. Once I get x, I make sure that it wouldn't make the denominator equal to 0, and then I need to check for common sense. So if x is 240, that means it would take Norma 240 minutes to paint by herself. When you double that, it would be 480 minutes for Clara. And now let's answer the question. That made sense. How long would it take Clara to paint by herself? It would take Clara 280 minutes to paint by herself. Can you do me a favor right now and give me a 1 through 5, even if you didn't get done in time, based on your understanding after the explanation, please? 1 through 5. Thank you. We're moving on to some sports problems and some testing problems next. So we're going to do that. Let me use an order here. Okay, so this is hard to understand if you don't understand the basic concepts of a free throw in basketball. It's okay if you don't. I had 3 out of 19 students in my previous hour that knew anything about basketball. That's okay. I'm not gonna test you on your basketball skills, but it will make a difference in how much I have to explain before we even do the math. Can you go into the chat box and put a smiley face if you understand the concepts of like shooting a free throw and free throw percentages? If you understand those concepts, give me a smiley face. If not, I'm going to spend if the majority of you are not, I'm going to spend a little more time explaining so you understand how I'm setting this up. Getting no smiley faces. Not even from Benny. I'm surprised. Okay, so free throws. Thank you, Benny. So free throws. If you get fouled, that means if somebody hits you, they hack you, right? In the act of shooting, or when you're dribbling the ball, or there can be technical fouls. Whatever the case, if there is an infraction, and you are sent then to the free throw line. So comparing it to, oh goodness, I don't know soccer very well, like penalty kicks, right? Like something like that at the end. This is not a good, I can't compare it to soccer. I don't know soccer. Okay, so anyways, this is where you're getting these free throw shots. So the time on the clock has stopped and you get to shoot this free throw. And generally, People do a lot better at shooting free throws because there's nobody trying to deflect the shot. The time is stopped. They get to relax and shoot these shots. So this particular problem is talking about two individuals, Terry and Lady. Now, if you are starting to fall asleep, wake up, because this is going to be set up differently than the last several problems that we've been doing. So we have Terry, and they talk about Terry has shot 53 free throws in a row, and he's made 24. Now, Lainey has been shooting a little bit longer. She came into the gym to practice a little bit longer. She's already shot 200 free throws, and she's recorded that she has made 117 of those. That does not mean 117 in a row. It just means out of the 200, she has made 117 while she stood at the line and shot. Okay? So let's just real quick, let's just see like who's a better free throw shooter. So don't do anything on the calculator. I just want you to put a T or an L. Based on looking at this, who do you think is better at shooting free throws? T for Terry or L for Lainey based on the patterns that we can see of how many they've attempted and how many they've made. Go ahead, please. T or L? Are you awake and paying attention? T or L? Okay, here's how you would figure it out. You ready? So you take already how many they've made. So for Terry, he's made 24. He's attempted. He shot the ball 53 times from this position, and from that position he's made 24. It's made over attempted. So if I put this into a percentage, we could say in our minds, okay, Terry has made 45% of those shots. Lainey, on the other hand, she's made 117 over 200. So she has, if we put it into a percentage, and we round it up, she's made 59%. So Lainey is clearly a better free throw shooter on this particular day. Now here's the question. Let's first take a second and let's talk about what this means. Consecutive. Consecutive. What does consecutive mean? Consecutive means one after one, okay? One after one. There's no break in between. One after one. You consecutively do something over and over and over again. Minimum is the smallest number. So what is the smallest number, the minimum number of consecutive successful? That means you're making a shot in this particular context. What is the smallest number of consecutive made shots that Terry must complete in order to surpass Lainey's free throw percentage? Remember, Lainey is at a 58.5, while Terry is only at a 45%. So what must he make consistently over and over again, hypothetically, in order for him to be better free throw shooter than Lainey? So what we do is we start with whoever's the better. Who are we trying to reach to? We're trying to reach up to Lainey's level. And I put down Lainey's level. And then we make a larger line, and who are we trying to have their percentage raised up to? So we want to take Terry's percentage and we want to raise it up. He has completed 24 of 53. Now, there may be people that are like, oh, that's not realistic. Well, within the context of this problem, we're just going to follow that. What is the smallest number that he must shoot in a row and make? So for every one he shoots, this is your attempts, for every shot he attempts, we assume he makes it. For every one we add, for every one he shoots, we assume he makes it. And we want to know, first of all, when would they be equal? So to solve this, let's take a break here and let's come right up here. If I gave you this and I said, please solve for x, because that's 2 of this. If I asked you to solve, you in 200. Times this quantity, times this quantity, 100 plus 200 plus 117x. Even though they're x again. You would use decimals because that's what I used earlier. Just make sure it's not right. So I have 200 subtract 117 is 83. Now again, as let's do this. 1401 divided by 83. I come up with, oh, and I didn't even type it in. So it is approximate that you should shoot, you attempt, you also smallest number that Terry must shoot and also make before his free point 8 pass. Better. So 0.5857. This is Terry. And this, now, are they extremely close? Of course they're extremely. Now has a slightly better free throw percentage. He now has a 7 here. And you're like, well, why can't I say 19? Still, if he attempts a minimum that he must shoot and be successful with before he surpasses. And the answer would be 17. If a factor, can I have a 1 through 5 on your, no, 1 through 5. 1 through 5? Two problems left, hang with me. Let's do that one last because it's large numbers and just setting it up. Well, let's do this one next, actually. So I'm assuming you don't know much about the ACT because the ACT exam, nobody in here has probably taken it yet, but the ACT exam is comprised of 4 sections. There's math and science and reading and English. And each test has a set amount of questions. And we're going to compare, just like we did free throws, we're going to compare Karen's percentage of correct answers with Sam's. Karen is taking a practice exam. She's made 37 out of 50. Sam's made 25 out of 42. How many consecutive questions does Sam need to get correct? So it's the same concept as basketball. For every attempt, they're saying moving forward, every consecutive question he attempts, Sam is also going to get it correct. It's like making the basket for everyone you attempt. So what does Sam need to do in order to meet Karen? What does Sam need to do in order to meet Karen? So let's write down what Karen is. Karen is 37 out of 50. Karen is 37 out of 50. We know Sam is only 25 out of 40. 25 out of 42, excuse me. And we're going to say, let's change this right now. How many consecutive questions does Sam need to get correct in order? We're going to say instead of match, in order to surpass. What is the smallest number? What is the smallest number of consecutive questions Sam needs to get correct in order to surpass? You may be wondering, why am I changing this? Because I know that your quiz questions and your test questions both specify the minimum number that's needed to surpass. Surpass means to go past, to be better than. Okay, same concept here. We're taking 50 times 25 plus x equals 37, and 42 plus x. And we would use Desmos just to save time and keep you awake here. I'm going to take 25 times 50, as you can see. 1250 plus 50x equals 1554 plus 37x. So I'm going to quietly continue to solve, and then we'll discuss the problem. So here's the answer when I solved. So Sam would need to correctly answer 23.346 problems in a row on this practice ACT before he would surpass Karen's percentage of correct answers. You can't complete 23.3. So what we would say as a complete sentence would be, again, we need to know what's the subject, what's the task, and then what's the answer. So if Sam completes 24 consecutive problems correct, he will surpass Karen's correct percentage. Can I have right now, and just honest answers, a thumbs up or a thumbs down, again, for how did I set it up, solve, and then how did I answer? That's okay. Thumbs up or thumbs down? We have one problem left today. You know, every sport does this in their own way. I believe that baseball throws out stats more than any other sport. If you were somebody or that has a family that enjoys watching baseball and you listen to it, it's always stats after stats after stats after stats. But this talks about two very famous quarterbacks. And like many of you have maybe grown up in families that, you know, loved watching following different soccer clubs across the world. I grew up in a family with 24 first cousins, and there was only 4 of us girls. And so, along with my father and uncles and cousins, we would often spend, you know, Sundays together. We'd go to church, go back to grandma's, eat, and then we would watch football. So it's kind of like part of, we'll say, in some ways, my culture and my family. And so this used to be a quarterback when I was really young. Unless you're really a guru of football, you may have not heard of him. His name is Dan Marino. He's one of the best of all times. And he was a quarterback for the Miami Dolphins. This, for those that follow football now, you may have heard of him in recent times. He now does some announcing and some shows on ESPN. And this is Manning, okay? There was 2 Manning brothers. This happens to be the older of the 2, Peyton Manning. Since I enjoy sports, and I know not a lot of you do, can I have a smiley face if anybody has even heard of these 2? Just curious, it's not going to help your grade. Has anybody ever heard of Peyton Manning or Dan Marino? Nobody. Ugh. Okay, so here we go. We're not going to actually, thank you. We're not actually going to take time to solve this. My thing is, do you know how to set it up? So we're going to take this like a quiz. It's not a quiz. I'm going to have you read this and just see, can you set up the equation? Don't take time to solve. And I'm going to give you a minute and a half. It's the last problem of the day. Go. We're going to use again the word surpass, since we know that's really what we see. I just noticed the time, and so I'm going to step in here. What do we need to do here? So we need to take Peyton and we need to raise him up to Dan's level to surpass it. So we know Dan is 4,763. I know I didn't give you the time that I thought. I lost track of the time in class, and that's why I'm starting now. Dan is, let's see here, he's 326 over 575, and what does he need to do? For every pass he's going to attempt, we assume he's going to complete it. Is it realistic? It's not realistic, but within the context of the problem, this is how we would set it up, and then you would solve from there. Okay? So this is the minimum number that he would need to attempt and complete in order to surpass, and we would solve.